Welcome back to the deep dive. Today, we're taking the scalpel to a pretty systemic crisis within modern science.
Mm,
It's a structural emergency, really, that affects everything from drug development all the way to climate modeling.
it's huge.
Yeah, we're talking about a system where critical papers can sit unpublished for months, sometimes years, just waiting for peer review.
Right, and that's not even the biggest problem. The core issue is trust.
Reproducibility crisis.
Exactly. Replication failure rates are often cited between 40 and 60%.
That's a staggering number. It means we can't really trust the foundations of the knowledge being built.
And this isn't because of, a lack of brilliant minds or a lack of effort. Our sources frame this as a structural mismatch.
A mismatch. How so?
The systems we use, journals, grant cycles, all that, they're just too slow, too centralized. They're too opaque for the sheer velocity of modern discovery.
So the machinery is seizing up.
That's the perfect term for it. The sources call it epistemic paralysis.
Mm.
We're drowning in data, but we can't synthesize reliable truth quickly enough.
Okay, so if the old machinery is failing, what's the radical prescription?
Well, that's our focus today. It's a convergence that promises to be the cure. DeScAI.
The fusion of decentralized science and artificial intelligence. And specifically, we're looking at the platform that seems to be leading this charge, Episteme.
Right. Epstein is proposing a completely new architecture for how knowledge gets validated, incentivized, and, governed. They call the framework epistemic accelerationism, or EPIAC for short.
And that's our mission for this deep dive, right? To analyze the foundational structure of Episteme, this five-stratum architecture they talk about.
Exactly. To really understand how it aims to bypass all that institutional inertia, speed up discovery, and try to make something as nebulous as truth into something programmable.
That is an immense mission. So let's start with the revolutionary shift. Science used to be, what, a library? Static PDFs, gatekeepers?
Right.
But Episteme wants to turn it into a conversation with real stakes. They say a scientific hypothesis should have a heartbeat. How do you even do that?
You do it by financializing uncertainty. That's the heartbeat.
Okay.
Episteme, which is currently running its testnet called Eidolon.
Which means image or phantom.
Yeah, suggesting it's the shadow of the system to come.
Yeah.
It's a platform for tokenized prediction markets for science.
Prediction markets.
Yeah.
That's fascinating. We see them for politics, for sports, but for fundamental science, that seems radical. How does that turn belief into liquidity?
It formalizes it. It puts a price on belief. You have users, researchers, investors, specialized AI agents, and they stake tokens for or against a specific hypothesis.
So the hypothesis becomes a living contract that's actively trading.
Precisely. You're converting belief into economic exposure.
Yeah.
It forces you to put your money where your expertise is.
And what keeps this thing alive? What drives that continuous recalibration of its certainty?
That would be the AI oracle. These AI oracles are constantly scanning the entire global scientific ecosystem. Not just published papers, but preprints, clinical trials, raw data, even code on GitHub.
And as new evidence comes in, the oracles feed that back into the market.
Continuously, adjusting the price of that hypothesis in real time.
So if a hypothesis is trading at, say, 75 cents on the dollar, that means the market is assigning it a 75% probability of being proven correct.
You've got it. And the accurate forecasters, the ones who saw it coming, they get rewarded financially. They climb a leaderboard based on their accuracy and their P&L, their profit and loss.
So the reward shifts from just academic prestige to verifiable predictive accuracy.
Yes, and that changes everything.
What I find really fascinating here is the idea of pre-validation, getting feedback long before you even submit a grant.
This could be a massive accelerant for research. Think about it. Instead of spending 6 months on a proposal just to have it torn apart by reviewers,
You can test the waters first.
you can use the market for early incentivized feedback.
Walk me through an example. How would this actually work for a research lab?
Okay, imagine a metabolic health lab. They have 3 candidate studies, let's call them A, B, and C, for a new therapeutic.
Right.
They turn the core hypothesis of each study into a market on Episteme. This isn't formal proof, of course, but it's a test of relative credence.
So what does the market tell them?
It tells them what the most informed people out there actually believe. So if the market prices study A's success at, say, a 0.62 probability,
62 cents on the dollar.
that's a strong signal.
Yeah.
It's plausible. But if study C prices at, like, 0.27, that's a blinking red light.
A huge red flag.
It suggests that the informed crowd, including these adversarial AIs we'll get to, they see a fundamental flaw in study C's design or premise.
So the researcher learns in real time where the skepticism is, and they can either fix study C or, pivot their funding to study A before they waste a ton of resources.
Precisely. It turns scientific inquiry from this static pass-fail judgment into a dynamic risk assessment. And that feedback loop is the engine of epistemic accelerationism.
Okay, let's unpack this then. This convergence of markets, AI, and crypto. It's not just thrown together, it's built on this complex theoretical structure called DeScAI. What are the core properties it's trying to guarantee?
The sources define three core properties. First is epistemic recursion.
Recursion, meaning?
It means the system has to continuously ingest and learn from its own outputs. Validation data, disputes, outcomes.
Yeah.
It all feeds back into the system to make it smarter and faster.
Like a machine learning model training on its own results.
Exactly. The second property is incentive alignment.
Making sure the rewards actually drive truthful, rigorous behavior.
Right. And the third is distributed veridiction. This means legitimacy doesn't come from some central editor or government agency. It emerges from auditable protocols that everyone can see.
Okay, so recursion, alignment, and veridiction, and all three are built into this five-stratum architecture. Let's walk through that blueprint, starting from the foundation.
We begin with stratum 1, the provenance substrate.
The immutable memory of science.
That's a good way to put it. It's the foundational layer ensuring everything is auditable. It anchors every single scientific artifact, datasets, code, protocols, using cryptographic hashes on decentralized storage like IPFS.
So if you change one byte of data,
The hash changes. The system knows immediately. Provenance isn't just a metadata tag. It's a cryptographically guaranteed chain of custody.
which makes reproducibility a default feature, not this academic struggle it is now.
Exactly. Any claim made higher up the stack has to trace back to the immutable data in S1. If it can't, it loses its veridiction score.
That makes sense. So we have the data anchored. Now, how does the system pay for the hard, rigorous work?
That's stratum 2, the value mesh, the economic layer. It uses two really powerful mechanisms. First is staking and slashing.
So if I make a claim, I have to put some money down, a security deposit.
Essentially, yes, you stake tokens.
Hmm.
If your claim is later proven false, you get slashed, you lose that deposit. And it gets distributed to the community members who correctly found the flaw.
That's a powerful deterrent against sloppy work. But what about the non-glamorous stuff, like just replicating someone else's study?
That's where retroactive public goods funding, or retro-PGF, comes in. It's a crucial idea.
Okay.
Instead of funding work based on a promise of future success, retro-PGF rewards work after its value has been confirmed. It funds proven rigor.
So it rewards the people who took the time to replicate Study A, or the ones who found the fatal flaw in Study C.
Yes, it makes rigor economically viable.
Okay, so S1, we have the immutable data. S2, we have the money aligned to reward rigor. But who or what is actually doing the work?
That would be stratum 3, the agent plane. This is where humans and AI really converge. It introduces what are called self-sovereign scientific agents, or SSAs.
Are these just fancy bots?
They're more autonomous than that. You can have hypothesis SSAs that are specialized in, say, protein folding, and they're just constantly generating new testable claims for the markets.
And crucial.
You also have adversarial SSAs. These are auditor agents. Their only job is to spot fraud, flag inconsistencies, and test the edges of a hypothesis. They are financially incentivized to find the flaws.
So you have an always-on layer of critical peer review.
Operating 24/7 under the economic rules of S2.
Okay, this sounds incredibly productive. But layer 4 is the trust layer. How do we actually know the claims these agents are making are computationally sound?
Right, that's the most complex piece. Stratum 4, the verification circuit, it provides cryptographic contestability. This is where zero-knowledge proofs, or ZKPs, come in.
Okay, let's pause on the jargon. For you listening, what's a ZKP?
In simple terms, a ZKP lets me prove to you that I performed a computation correctly without revealing the underlying data.
Which in science is revolutionary.
Totally. And then you have ZKML, zero-knowledge machine learning.
Oh,
This would let a researcher run a proprietary AI model on a huge sensitive data set and then cryptographically prove the output is correct, like a new drug target, without ever revealing the private data or the secret sauce of their model.
it validates the computation without revealing the data. That solves a huge bottleneck.
It does. And the ultimate output of this layer is the veridiction score, the VS.
The VS.
Think of it as a real-time reliability index. It tracks everything: provenance from S1, replication success, governance votes. It turns validation into an auditable programmatic score.
And that leads us to the top layer, stratum 5, which governs the rules of the whole game.
Stratum 5, the governance canopy. This is the meta layer. It defined how the rules of S1 through S4 evolve over time.
We hear about governance problems in DAOs all the time, though. Power just concentrates with the wealthiest actors. How does Episteme try to fix that?
It relies on something called polycentric coordination. So instead of one single DAO voting on everything, you have multiple coexisting decision centers.
Different groups for different things.
Right. Maybe one chamber for identity-based voting, another for technical experts. The goal is always transparency and contestability, making sure the rules themselves can't be captured.
Okay, and this is where it gets really interesting for me. How is this entire complex stack secured? And is anyone actually building this?
They are. And the security is anchored in fairness as a first principle. Episteme is built on the Humanode Layer 1 blockchain.
And the whole point of Humanode is to counter those typical failures, right? Prestige monopolies in science and plutocracy in crypto.
Exactly. It uses cryptobiometric uniqueness to enforce one human, one node, or 1H1V.
So no bots, no single person pretending to be 1,000 people.
It makes the whole system Sybil resistant. It prevents bots or wealthy whales from distorting the prediction markets or just seizing control of the governance protocols in S5.
Which makes the market signals way more reliable. You know they're coming from a diverse pool of actual humans, not just consolidated capital.
Absolutely. And when you look at the empirical evidence, the 14 projects we analyze in the sources, you see this clear pattern emerge. They call it diagonal maturity.
What does that mean, diagonal maturity?
It means projects aren't just perfecting one layer at a time, vertically. They're maturing diagonally across the strata. The lower layers, S1 for provenance, S2 for incentives, S3 for agents, those are the most robust right now.
Can you give us a quick example?
Sure. A project like Vida.AO, which focuses on longevity research, they use IP NFTs to anchor the rights to their funded projects.
Okay.
That shows strong maturity in S1 and S2.
Okay.
Or a platform like ElizaOS, which is all about spawning multi-agent swarms for computational biology. That's clear maturity in S3. The tech to anchor data and align incentives is here.
But where's the gap? If the lower layers are working, what's the bottleneck?
The bottleneck is clearly in the upper strata. S4, the verification circuit, and S5, the governance canopy. For most projects, these are still just on the roadmap.
So we're still missing that robust cryptographic verification.
That's the critical gap. Most systems are still relying on human milestone checks, not trust-minimized proofs of computation.
This whole model is about acceleration, but acceleration is risk at velocity. What are the main failure modes we need to worry about?
The sources outline 3 big ones. The first, and maybe the most immediate, is hallucination risk.
This goes back to the AI agents in S3.
Precisely. If you have these powerful LLMs generating research summaries, they can easily introduce factually false but plausible-sounding information hallucinations into that recursive loop.
And bad data in means garbage out.
Exactly. It degrades the whole system. The mitigation has to be strict. Cross-agent consensus checks and mandatory ZKML inference proofs, where the agent proves its data is sound.
Okay, and the second risk. It goes back to the market for truth idea. What happens when profit contaminates the science?
That's the big one. The market-derived truth, or Goodhart danger.
Goodhart's law. When a measure becomes a target, it ceases to be a good measure.
You've got it. If scientists start optimizing their research just to maximize profit in the market, they might chase what's speculative or sensational, not what's true or foundational.
So how do you stop this from just becoming another crypto hype cycle?
The mitigation is crucial here. Episteme has to treat the markets as heuristic validators, as signals, not as the ultimate arbiters of truth.
So how do you counterbalance them?
You route a significant portion of market fees away from traders and use it to fund external, independent replication studies. The economic activity literally pays for the empirical rigor pipeline.
That closes the loop nicely. And the final risk. Failure at the top in S5.
Governance drift. We've seen it time and again. Power concentrates. Even in DAOs, 1% of token holders often end up with 90% of the voting power.
And that undermines the whole point.
It does. The system trying to mitigate this with that identity-anchored voting from Humanode, the 1H1V, to make sure financial whales can't just take over the rules of science.
So if this incredibly complex architecture actually works, what are the 3 key transformations we should expect to see?
DeScAI is designed to achieve 3 things. 1, cycle time compression, shrinking that path from hypothesis to verifiable resolution from years down to, potentially, weeks. epistemic pluralism, fostering a much broader diversity of tested hypotheses by opening up funding and verification beyond just a few institutional silos.
And the third, which is maybe the most important for public trust.
Reproducibility amplification, improving overall trust, not just through reputation, but through transparent, auditable protocols that anyone can check.
So ultimately, the goal here is to move science from these static, gate-kept archives to a living, self-correcting economy where knowledge is constantly being tested, priced, and updated right out in the open.
It's a shift from knowledge as this fixed object of institutional authority to knowledge as a dynamic, auditable function of a collective process.
Which brings us to a final provocative thought for you to consider, and this comes directly from the source material. If accountability, incentives, and identity are hard-coded into the foundations of knowledge S1 through S5, are we witnessing a transition from institutional truth
Right. Truth based on prestige, on who you are.
to what they call infrastructural realism, truth based purely on a transparent, auditable process?
That's the big wager Epstein is making, that if you can guarantee the fairness and reliability of the process through the infrastructure itself, the knowledge that comes out of it becomes the new definition of what's real.
Fascinating stuff. Thank you for joining us for this deep dive into the accelerating frontier of science. We hope this knowledge helps you stay ahead.